So we just got done talking about how molecules might have a bipolar or nonpolar, and if they're polar, they're either dipole-dipole or hydrogen bonding, and if they're nonpolar, they are London dispersion forces. This leads us to why atoms have the different phases, right? You've heard in other classes you have a gas, a liquid, and a solid phase. These intermolecular forces play a big role in this. If I am in a gas phase, my atoms, my molecules are moving very, very quickly. So the intermolecular forces can't form. It's kind of like if you tried to bungee jump with a rubber band. Okay, you are moving too fast, you weigh too much, and the band's going to snap. The intermolecular forces snap because the molecules are moving so quickly. That motion of the molecules, we usually talk about it as it is too hot. Okay, motion and temperature are the same thing when it comes to chemistry. The faster something moves, the more hot it is. So if those molecules get slowed down, or if the intermolecular forces are strong enough, it goes from a gas to a liquid. All right, and so that's what. And so now my liquid molecules start partially bonding to each other. And so when something tries to move through here, it doesn't just move out of the way, it has to overcome this force. That's why when you dive into water, you feel it. Instead of just when you walk through air, you don't really feel anything, maybe a slight breeze. Because you have to break through these forces that are holding those molecules together. All right, and then so when we go from a liquid to a solid then, now the molecules can't even move. They are stuck in a rigid arrangement. Okay, they don't move, so you cannot go through it anymore. That's hence solid. You can't move through it because those intermolecular forces have gotten strong enough. This is why when you move, you don't fall apart. Your molecules are held together by intermolecular forces. So this gives rise to, you can see something that looks like this, where if I start heating something up, a solid up, all I'm doing is increasing the motion. Once I get to the part where it is actually converting from a solid to a liquid, change in temperature stops. All right, it will not change temperature again until all of the solid has become liquid. Then it increases, then it starts turning into a gas, and then it increases. Again, here you do not have a change in temperature. So for water, 32 degrees Fahrenheit is here, and it will not change until you have either frozen it and then you can cool it down some more, or you have melted it and then you can heat it up some more. But you will stay at this temperature until that happens. 212 degrees is the boiling point, and it will stay at that temperature until it is all liquid or all gas. It will not change until that happens. All right. Some results of that: it warms up when it snows. You cannot cook faster by turning up the heat. Cannot boil something faster. Right? Because the water temperature will not change. It will just evaporate faster. And last, a lot of ice in a drink doesn't make it colder. It makes it colder longer, but not colder overall. All right, so that's the phases. That's why they are there. That's what's happening with intermolecular forces in phases. And we will be moving on now to colligative properties.